See now, what is the first index number? First weighted index number is, what is that, last pairs index number or last pairs method. So this method was divided by the last pairs in 1871. In this method, the weights are determined by quantities in the base. See now here P1 is what? Current year price. P0 means current year, old year or base year price. Then Q0 is old year quantity or base year quantity. So with the help of base year quantities and current year price and base year price, then I have to define this formula. So last per index number, then P0 1 is equal to summation P1 Q0 by summation P0 Q0 into 100. That means what? The current year price multiply with the base year quantity. Then again you have to find out, after finding products, again can find out what is the sum of all the products of P1 into Q0 by similarly summation P0 Q0. The base year prices multiply with what is there? Base year quantities. Then again, after multiplying, I have to find out summation. So summation P1 Q0 by summation P0 Q0 into 100. So this is the what is there? Last pairs method formula or last pairs index formula. Then next one, Fauche's method. Fauche's. So this method was devised by German statistician Fauche in 1874. The weights of current years are used as a base years in constructing the Fauche's index number. So now here again the notations are same. Then what is there? Fauche's methods are Fauche's index number notation is P0 1 equal to summation P1 Q1 by summation P0 Q1 into 100. So summation P1 Q1. So P1 is what? The current year prices are multiplied with the current year quantities. Then after that again you have to find out the summation of these all values. Then denominator, so P0. P0 is what? Base year prices are multiplied with the current year quantities. Then what is there? Again you have to find out sum of all these values into 100. So now, so P0 1 equal to summation P1 Q1 by P0 Q1 into 100. So next formula is Darvish and Bowles method or Darvish and Bowles index number. This method is a combination of last pairs and Fauche's methods. If you find out the arithmetic average of last pairs and Fauche's index, we get the index suggested by Darvish and Bowles. So now here the P01. So P01 means what is there? Loss pairs and Fauche's. By using these both formulas, again we are finding average of loss pairs and Fauche's that maybe can be divided by 2. Then maybe have to obtain Darvish and Bowles. So simply P01 equal to L plus P by 2. L is nothing but loss pairs formula plus P is nothing but Fauche's formula by 2 into 100. Or then how to substitute loss pairs formula. Then what is there? Summation P1 Q0 by summation P0 Q0 plus summation P1 Q1 by summation P0 Q1 then by 2 into 100. Okay. Simply after finding last pairs and Fauche's, then what is there? I have to find out average of last pairs and Fauche's. Then you can get what is there? Darvish and Bowles index number. Then now Fisher's ideal index. So this is very important index number. Very important index number. So why? Because see here more than 100 index numbers are there. Out of this all index numbers, the Fisher index numbers is only called what is their ideal index number. Fisher index number is only called ideal. So why? Because the Fisher index numbers only satisfies what is their different tests. Okay, like TRT and FRT. So TRT is nothing but time reversal test. FRT is nothing but what is there? Factor reversal test. Factor reversal test. Okay. So now the Fisher index number The Fisher ideal index number is the geometric mean of the class pairs and Fauch's index number. So P naught 1 equal to square root of summation P1 Q naught by summation P naught Q naught into P1 Q1 by P naught Q naught P naught Q1 into 100. That is simply can write as this is P naught 1 equal to square root of L into P. L into P. L means what? Last pair formula into Fauch's then into 100. But this 100 is what? Outside the square root. Outside the square roots. Okay. So P naught 1 is equal to square root of summation P1 Q naught by P1 naught Q naught into P1 Q1 by P naught Q1 into 100. Okay. So this is what is the Fisher's index number. So next one, Marshall-Edgeworth method. What is the next formula? Marshall-Edgeworth. In this index number, the numerator consists of an aggregate of the current year price multiplied by the weights of both the base year as well as the current year. Okay. So then P naught 1 is equal to summation P1 Q naught plus summation P1 Q1 by summation P naught Q naught plus P naught Q1 into 100. So this is what is their Marshall-Edgeworth formula. Then next one, Kelly's method, Kelly's formula, Kelly's index number. So Kelly's think that the ratio of aggregates with selected weights, not necessarily of the base year and current year, give the base index number. So now here the P naught 1 equal to summation P1 Q by P naught Q into 100. See here P1 is current year price, P naught is base year price. But what is about Q? So there is no naught and 1. That means what? Is not a base and not a current year. So only Q is there. So Q refers to the quantities of the year which is selected as the base. Q refers to the quantities of the years which is selected as the base. That is what is there Q. So now, so basing on this, how to solve the problems. Okay. So maybe these problems are important for theory and practicals. Okay. So now here different types of index numbers are there like for Kelly's, Fauch's, Darvish, Bowles. Okay. Fisher index numbers. But by using formulas, then how to solve the problems, I will say next.